Welcome to a lesson with Dr. Powell. Let's take a look at the triple integral that we set up in the last video and work through the computation. So right here, we go to the innermost part, take the antiderivative with respect to z, evaluate from 0 to negative y, and simply this portion right here will simply become negative y. So plug in negative y and 0. This part right here just becomes negative y. Okay, so do that. All right. All right. Now we go to the next bit and we compute this. Take the antiderivative with respect to y. And we get negative y squared over 2. And we're evaluating between these 2 points. So plug in 0 and then subtract off what happens when we plug in this. Now, when we plug in this, we're going to square it. So this negative doesn't matter, but this negative is still here. When we subtract negative, negative becomes a positive. So we're going to end up from this piece right here, we'll end up having 1/2 multiplied by 1 minus x squared, because we've squared the square root. Remember, it was negative y squared over 2 between those 2 points. And when we plug in this one, that's what we get here. Okay, so then that's what we have for the next bit. So now we just have an integral with respect to x. And taking the antiderivative, this is just a constant multiple that can factor out here if we would like. Honestly, this is even. This is an even function. It has an even symmetry if you plug across the y-axis. It's just very symmetric. So all we have to do is just integrate on one part of it and we'd get it. So we just need to go from 0 to 1. We can double the result of going from 0 to 1. The doubling will cancel with this 1/2. So this can just be equal to, without the 1/2, just the integral from 0 to 1 of 1 minus x squared dx. A little technique via symmetry. Taking the antiderivative, we end up getting x minus x cubed over 3, go from 0 to 1, and this will just end up being 1 minus 1/3, which is 2/3. So we've just computed the volume that was discussed in the last video, and we found it to be 2/3 using a triple integral. Thanks for watching.